option B. From number 97, option B.
Yes, sir.
Correct. Option B is perfect answer. Yes, did you get 97? 97 ka B?
No, sir, I was solving it because I just joined now.
Just try it. 97, I think correct option you will get B.
Yes.
Look at 98. Simple sum again. A star behaves like perfectly black body emitting radiant energy. Ratio of radiant energy emitted per second by this star, ratio of radiant energy emitted per second by this star to that by another star. So first star to that by another second one is how much? Another star having 8 times the temperature of former. So temperature of another star is 8 times, radius of another star is 8 times the previous one, and Kelvin temperature is 1/4 of the previous one. So rate of radiation means A is sigma T raised to 4. So first upon second is R1 upon R2 square into T1 upon T2 raised to 4. R1 upon 8 R1 square T1 upon 1/4 of T1 raised to 4. So 1 upon 8 square is 64. 4 raised to 4 is 256 equals to 4 is to 1. 4 is to 1. That is option. Completed.
Yes, sir.
Two balls A and B are made up of same material, but diameter of B is twice that of A. Diameter is twice means radius is twice. Both are heated to same temperature and then placed in the similar surrounding. Let the rate of loss of A be RA. I'm writing small a to avoid confusion. Rate of radiation of A and that of B is RB. Then which of the following is correctly describing the relation between rate of loss? So rate of loss of A to that of B, if everything is same, is RA upon RB the whole square. RA upon 2 times RA the whole square equals to 1 by 4. So 4 times RA equal to RB. 4 times RA equal to RB options.
Done, sir.
Sum number 100. The body cools, that means d theta by dt, cools at the rate of 3 degrees Celsius per minute when it is at temperature of 50 degrees Celsius. First rate of cooling. If the temperature of surrounding is 25 degrees Celsius, then the rate of cooling of the body is how much? At 40, the temperature of 40 degree, what is the rate of cooling is C into theta minus theta. So first rate of cooling upon second rate of cooling, CC will get cancelled. It is 50 minus 25, 40 minus 25. So 3 upon second rate of cooling is 25 upon 15. 5 into 3, 5 into 5. So second rate of cooling will be 3 is a 9 upon 5, 1.8 degrees Celsius per minute. That is option.
None.
1, 0. A sphere of density rho, specific heat capacity C, and radius r is thermally insulated thread in an enclosure which is kept at lower temperature than the sphere. The temperature of sphere starts to drop. Temperature of sphere starts to drop. That means rate of fall of temperature at a rate which depends upon the temperature difference. First depends upon this. And the nature of the sphere. Nature of the sphere. And is also proportional to here. So whenever specific heat given and rate of cooling d theta, start with heat formula first. It is mth theta. So dq by dt will become ms d theta by dt. dq by dt is k into theta minus theta 0 by Newton's law. M is density into volume of sphere 4 by 3 pi r cube. Specific capacity given C into d theta by dt. So k theta minus theta 0 upon rho into 4 by 3 pi r cube C equals to d theta by dt. So d theta by dt will be proportional to theta minus theta 0 nature and also 1 upon r cube rho C. So option.
Yes, sir.
A perfectly black body emits radiation at temperature T1 Kelvin. If it is to radiate heat 16 times, that 16 times this power, 16 times this power, then what will be done? Orally, can you see? Radiation becomes 16 times power, temperature should be how much? 2 times, because rate of radiation is fourth power of temperature. But directly it clicks. Directly you follow why I said 2 times? Because
Yes, sir.
2 raised to 4 is 16. Doesn't click, then you have to write this ratio. T1 upon T2 raised to 4, R1 upon 16 R1, T1 upon 4 to 1 upon 2 is T1 by T2. That's the T2 is 2 by
Done, sir.
1 upon following solid objects are made up of same material and same surface. Same material means rho is same surface means E is same, and same finish. Are maintained at temperature of 300 Kelvin and surrounding is at 350. So temperature and the surrounding is also same, which will exchange radiation with the surrounding with minimum rate. Everything is same. For minimum rate of exchange, area should be minimum. So I'm just checking which rate will be minimum. Area will be minimum. Solid sphere of radius r, area will be 4 pi r square. Without checking with other, I don't know whether this is minimum or maximum. Solid hemisphere area will be 3 pi r square. So at least in this is cube of edge r. So surface area will be 6 r square. 4 3 12 12 इसमें ये minimum अभी तक cube. Solid cone of radius r and height, cone of radius r and height h equal to 2r. Surface area is pi r into r plus l. So it is pi r into r plus greater than 2r. So it will be pi r something greater than 3r. So it will be greater than 3 pi r square. So that means 2 is least. Then its surface area appears to be this one. This is approximately 12, 9. This is greater than 9 r square. So this is this. Hello?
Yes, sir.
So object C will have minimum area, therefore it will give minimum exchange. Right.
Done, sir.
The radiation emitted by star A, radiation emitted by star A is 10,000, that means 10 raised to 4 times that of sun. If the surface temperature of sun and star A are 6,000 Kelvin and 2,000 Kelvin respectively, then ratio of radius of star A to sun. So rate of radiation is A E sigma e raised to 4. That means rate of radiation of A to that of sun will be 4 pi r of A square 4 pi r of sun square. E sigma same cancel, temperature of A upon sun raised. So 10 raised to 4 r of sun 4 pi 4 pi. Radius of A to that of sun we have to calculate. Temperature of sun is 6,000 and A is 2,000. 2 into 3 is 6. This is 10. So 10 raised to 4 RA upon R of sun square into 2 raised to 4 will be 81 3 square 2 square 16. 2 raised to 4 16 3 raised to 4 is 8. Therefore RA upon R of sun square is 10 raised to 4 into 81 upon 16 taking square root. RA upon R sun is 10 raised to 2 into 9 by 4. That is what option number 2. Option C 1 is 2. This is 100 4 into 9. 10 raised to 4. Temperature of A is 2000. So 2000 पूरा है. 900 is to 1. 900 is to 1. Yeah?
Yes, sir, done.
A hot liquid in a big room is kept in a big room. Logarithm of numerical value of temperature difference, that is theta minus theta 0, and the room temperature difference between liquid and room is plotted against time. Then the plot will look like what? Logarithm and time we have to plot. How the plot will look like? By Newton's law of cooling, we know rate of cooling is proportional to or equal to C into theta minus theta. So from dt I want to get T. So I can just rearrange this. Theta minus theta 0 C. After integrating d theta upon theta minus theta 0 is the integration of dt. We get log of theta minus theta 0 is Ct plus some constant of integration. So this we are taking along y, time along x. What will be the nature? Is it straight line? So this is of type of straight line. So hello,
Yes, sir.
this nature becomes y equal to mx plus c in straight line.
Yes, sir.
Just write information. Why we got straight line, then reveal that answer. It is a straight line option. First from here you start so that you get the nature y equal to mx plus c, which is straight line.
Done, sir.
One not six. A metal sphere cools from 64 degrees Celsius to 50 degrees. See, when the body cooling interval is given, please draw this flow chart. So cooling from one temperature to another in time 10 minutes, and then to 42 degrees Celsius in next 10 minutes. The ratio of fall in temperature in first two intervals will be how much? So it's very simple. Ratio of fall in temperature, direct we can write in first two intervals. First it is going from 62 to 50 in 10 minutes upon 50 to 42 in next 10 minutes. 10 cancel. So this becomes 14 upon 8, which is 7 upon 4. Option.
Done, sir.
Is coming. One not seven. In the above question, temperature of surrounding is about how much? So it is in connection, temperature of surrounding given. d theta by dt of first one upon second one, we can say c into, whenever it is interval, take average. Theta 1 plus theta 2 upon 2 minus theta 0, then theta 2 plus theta 3 upon 2 minus theta. This we got 7 by 4. Cc will get cancelled. First temperature was 64 plus 50 upon 2 minus surrounding. Then it is 50 plus 42 upon 2 minus surrounding. So we get 7 by 4 equals to 114 upon 2, 57 minus theta 0. 92 upon 2, 46 minus theta 0. So 7 times 46 minus theta 0, 4 times 57 minus theta. 7 into 6, 42. 7 into 7 into 4, 28. And 4. 28 and 4 is 32. Minus 7 times. 4 into 7, 28. So 228 minus 4 times theta 0. So 3 times theta 0 is 322 minus 228. Therefore 3 times theta 0 equals to 12 minus 8 is 4. This is 0, 1. Theta 0 is 104 upon 3. 3 3s are 9. This will become 11 minus 2, 94. So 3 3s are 9. 3 into 2, 6. This will be recurring. So they want is about how much? 31. 3 into 3, 9. 3 1 are 3, 3, 3. So this is about 31 degrees Celsius option. Whenever temperature is given from one point to another, take average temperature as theta.
Done, sir.
A body takes 4 minutes to cool from 100 degree to 70 degree. If room temperature is 50 degrees Celsius, then the time taken to cool from 70 to 40 degrees Celsius will be how much? Again, it is interval of temperature. We will do by Newton's law. Theta is average temperature. So directly I am writing. D theta is 100 upon minus 70. Time is 4. Second interval 70 minus 40, time we have to calculate. CC will get cancelled. 100 plus 70 upon 2 minus 15 upon 70 plus 40 upon 2 minus 2. So 30 by 4 into T2 by 30. 170 upon 2 is 85. 85 minus 15, 7. This is 110 upon 2. 55 minus 40, 15 is 40. 0, 0, yes. So this will be T2 upon 4 will be 7 upon 4. Therefore T2 equal to 7. Option.
Done, sir.
109. Circular disc A and B with equal radii. Radius of A and B are same. Are blackened. They are heated to same temperature and cooled under same surroundings. What inference you can draw from their cooling curve? These are cooling curves. Theta 1 minus theta 0. R is rate of fall of temperature and their radius are same. We want specific heat relation with this curve. Whenever specific heat comes and theta given, we start with this ms theta. So K into theta minus theta 0 is m into s into d theta by dt, because dq by dt becomes m s d theta. So K upon ms into theta minus theta 0 is d theta by dt. So d theta upon dt upon theta minus theta 0 will become K upon ms. That is change in y coordinate upon x coordinate. Yeah, directly लिख दो slope है. This is slope, ना? Y upon x. Hello?
Yes, sir.
So slope is k upon ms. That means slope is inversely proportional to specific heat. Which curve is having more angle made with x-axis? A or B?
A.
The slope of A is greater than slope of B. That means specific heat of A is less than specific heat of B. Check. Specific heat, there is B is found. you complete, then please try 110. I want that how many of you are getting correct answer.
Sir, option C.
Yes. Others got the answer? As 12 minutes for next one.
Yes, sir.
110. It cools from 55 to 45 in time 8 minutes. How much time it will take to cool from 45 to 35? So 55 plus 45 upon 2 minus surrounding temperature is 20. 45 plus 35 upon 2 minus 20. So 10 upon 8 into T2 by 10 equals to 100 upon 2, 50 minus 20 is 30, 40 minus 20 is 20, this is cancelled. So it becomes T2 is 24 upon 2 equals to 2. Okay. Now we have completed all radiation part. Open page number 9. Page number 9. Did you come to first question?
Yes.
This is of KPG part we are starting now. Product synopsis. What are real gases? Do they obey ideal gas equation or not?
Yes.
No, real gas will not obey ideal gas. No? They should become ideal first.
Yes, sir.
So real gas means they attract each other. And ideal means they never attract each other. They also attract each other. It's called real. They do not obey ideal gas equation. So what should I do so that real will become ideal? That means they should not attract. Should I increase the temperature or decrease the temperature? The temperature badaya, so molecule will come closer or move away.
away.
If they move away means they will not attract because attraction के लिए एक range होता है. If I decrease the pressure, what will happen? They will come closer or they will move away.
Move away.
So that means pressure decrease, temperature increase, then real gas will behave as ideal gas. Okay.
Yes, sir.
If it is becoming ideal gas, then only it will obey ideal gas equation. Just write this much. Kamya, you studied radiation ka theory from 12th standard.
Yes, sir.
आज लेकिन से पढ़ना.
हाँ, sir.
But then when you study synopsis and then MCQ, you will find it far better position.
Yes, sir.
The paper is going to come easy, so you have to be very careful about silly mistakes. And one or two difficult means you should be able to do that. If full paper is difficult, then it is not tension. But if it is easy, then it is full tension. Shall I clear it?
Yes, sir.
So real gas will behave as ideal gas when pressure is kept low and temperature is made high. What is ideal gas equation? Actually ये KTJ ना थोड़ा chemistry है. What is ideal gas equation?
PV equals to nRT.
P equal to nR. In this, what is P?
Pressure.
Pressure. And B?
Volume.
And
Number of mole.
number of moles. Huh?
Yes.
What is number of mole?
Of gas.
It is ratio of given weight upon molecular weight or molar mass. Huh?
Yes.
That means whatever is mass of gas divided by its molecular weight, it will give you number of moles. Yes, followed?
Yes, sir.
Yes, sir.
Now, can you tell me if number of mole is 1, then can I say mass equals to molecular weight?
Yes.
So for 1 mole of gas, what mass we are considering? Molecular weight?
Yes, sir.
1 mole is equivalent to how many molecules? Avogadro's number
Yeah.
Yes, sir.
denoted as Na. So now I get 3 things. 1 mole is equivalent to Avogadro is equivalent to molar mass expressed in gram. What is Avogadro number? Value?
6.023 into 10 raised to 22.
10 raised to 23. If
Yes.
it if mass is in gram, if it is kilomole, then it will become 226. Solve.
Done, sir.
Okay.
Yes, sir.
The ratio of number of molecules. What is ratio of number of molecules? See, suppose it is 1 mole, then how many molecules will be present? Avogadro number?
Yes, sir.
For 2 mole,
2N.
When
times Avogadro. 3 mole, 3 times Avogadro. So n mole will contain how many molecules? N times Avogadro number? Hello?
yes,
Yes, sir.
Can I say ratio of number of molecules is equals to ratio of number of mole? Number of molecule is nothing but ratio of number of mole. Okay? Yes? Any doubt in this?
No, sir.
Okay. Write this, then basic assumptions we are doing of KPG. Basic assumptions of kinetic theory of gases. First, can we see gas molecule? Yes, any of you can see the gas molecule?
No, sir.
No, because of poor eyesight? क्या आयुष आँख खराब है इससे क्या?
No, sir.
तो मतलब बहुत छोटे रहते हैं इसलिए नहीं दिखता है ना. तो पहले आ गया गैस कंसिस्ट ऑफ large number of extremely small molecules. Suppose I take container where we have got all oxygen, 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 oxygen. So all the oxygen molecule will be identical or it will be different? Each gas molecules are identical rigid spheres. Okay, identical rigid spheres. Copy.
done, sir.
Are the gas molecule in the state of rest or random motion?
Random motion.
So that means the random motion is also called sometimes zigzag or Brownian motion. So they are in state of random motion. If they are in random motion, hence they collide with each other. Hence they collide with each other.
Yes, sir.
And what is nature of collision? Elastic or inelastic? Perfectly elastic. That means it will rebound back with same velocity. That is, it rebounds back with same velocity. What is distance covered between successive collision called? Yes, distance covered between successive collision is called as what? Distance covered between successive collision is called as what?
Free path.
What is average of large number of free path called as?
Mean free path.
Yes. Free path is called as mean free path. This time of impact is large or small? Small. So it is called negligible, no? As compared to time taken for successive collision. Please copy this much. For 12th वाले के लिए important है, they can ask you any 2 or 3, maximum they ask 6. What to do? Tell me. 9:30. Tomorrow I'm back. Tomorrow my lecture is starts at 7:30. 7:30, 8:45, 9, 10, 11, 12:30. I can take it 12:30. But again, your sister will have class. Yes, sir, class. But I see he is running his snacks the computer and sister. ठीक है. हाँ, sir. Hello. 6 points over.
Yes.
Yes, sir.
Last. Average kinetic energy is directly proportional to the absolute temperature. Directly proportional to the absolute temperature. चार definition भी कर देता हूँ. What what is free path? Yeah, अभी पता है? Distance covered between successive solutions. And mean free path? What is mean free path? Average of large number of free paths. Let lambda 1, lambda 2 up to lambda n be n free paths. Therefore, mean free path lambda bar will be lambda 1 plus lambda 2 up to lambda n divided by n. Or, ये बहुत important है. Mean free path is also given by lambda bar equals to 1 upon root 5 n d square. N is molecular density. That means number of molecules per unit volume. Molecular density. And D is diameter of molecule. Gas. Copy this to definition.
Done, sir.
Mean velocity. Then mean square velocity. Then RMS velocity. The mean velocity is given by c bar equal to c1 plus c2 up to cn divided by n, where c1, c2, c3 are velocities of n gas molecule. Mean square is c square ka average. It is c1 square plus ct square up to cn square divided by n. RMS velocity is square root of mean square, which is root of c1 square plus c2 square up to cn square divided by n. C square bar and C bar ka square, are they same? Yes, are they same or different?
Different.
ये C bar का स्क्वायर मतलब इसका स्क्वायर है ना, करेक्ट? हेलो,
Yes.
अभी इसका स्क्वायर करूंगा तो डिनोमिनेटर n स्क्वायर होएगा ना? यस और नो?
Yes, sir.
मतलब या डिनोमिनेटर बहुत ज्यादा, इसलिए हमेशा याद रखना मीन स्क्वायर इज ग्रेटर देन स्क्वायर ऑफ मीन वेलोसिटी. What we tell is today will stop here. Tomorrow's timing you are knowing, lecture timing 9 to, yes Aryan, tomorrow's timing
So 9 to 10.
9 to 10. yes, थोड़ा एक्सटेंड कर दोगे 10:30 तक?
Okay.
जमेगा 10:30 एक्सटेंड किया था?
Yes, sir. चलो.
9 to 10.
Yes, sir. Done, sir.
That's all. Those who are in 12th, please complete radiation full. Tomorrow I will take 5 of yours. And then by Sunday, KT